In this part of laws of motion, you will study about circular motion of a car on a banked road. Banking of roads. In case of horizontal road, necessary centripetal force mv square by r is provided by static frictional force. When heavy vehicles move with high speed on a sharp turn, then all the factors contribute to huge centripetal force which is provided by the static frictional force and may result in a fatal accident. The large amount of friction between the tires and the road produces considerable wear and tear of the tires. And to avoid this, the kart road is given an inclination sloping upwards towards the outer circumference. This reduces wearing out of the tires because the horizontal component of the normal reaction provides the necessary centripetal force. As shown, consider a car of weight mg going along a curved path of radius r with speed v on a road banked at an angle theta. The forces acting on the vehicle are weight mg acting vertically downward, normal reaction n of the road acting at an angle theta with the vertical, and on resolving it you will get two components. N cos theta will be vertically upward. Force of friction small f acting downwards along the inclined plane. And on resolving this small f, there will be two components, f cos theta along the center of the curved path and f sin theta vertically downward along with the weight. So n cos theta will be equals to mg plus f sin theta, and the centripetal force is provided by the horizontal components of n and frictional force f. So n sin theta plus f cos theta will be equals to mv square by r. But you know that the f is less than equals to mu s into n. Thus, to obtain V maximum, F will be equals to mu s into n. Therefore, the equations 1a and 2a will become n cos theta will be equals to mg plus mu s n into sin theta, and n sin theta plus mu s into n cos theta will be mv square by r. And from these two equations, after solving, you will get V max equals to Rg into mu plus tangent theta over 1 minus mu tangent theta under the root. Comparing this with equation V max equals to mu s into Rg under the root, we see that maximum possible speed of a car on a banked road is greater than that of on a flat road. When there is no friction between the road and the tires, mu will be equals to 0, so that the safe limit for the maximum speed will be equals to V equals to Rg tangent theta under the root. At this speed, frictional force is not needed at all to provide the necessary centripetal force. And the angle of banging theta for minimum wear and tear of tires will be tangent theta equals to V square upon Rg. Banking of roads. In case of horizontal road, necessary centripetal force mv square by r is provided by static frictional force. When heavy vehicles move with high speed on a sharp turn, then all the factors contribute to huge centripetal force which is provided by the static frictional force and may result in a fatal accident. The large amount of friction between the Suppose the cyclist bends inwards through an angle theta with the vertical. The horizontal component n cos theta will balance the weight and n sin theta will give you the necessary centripetal acceleration. So n sin theta will be equals to mv square by r and n cos theta will be equals to mg, and by using these two you will get tangent theta equals to v square by rg. And you can say that the theta is equals to tangent inverse of v square by rg. This is the angle theta through which the cyclist bends would be greater if the radius of the curved path is small or the curved turn is sharp and the speed of the cyclist is large. Let's solve a numerical problem of NCERT numbered as 5.10. A cyclist speeding at 18 km per hour on a level road takes a sharp circular turn of radius 3 meter without reducing the speed. The coefficient of static friction between the tires and the road is 0.1. Will the cyclist slip while taking the turn? On an unbanked road, frictional force alone can provide the centripetal force needed to keep the cyclist moving on a circular turn without slipping. So by using the equation v square less than equals to mu s into rg, which we have derived in the last topic, and by putting the value of rg and mu s, you will get v is equals to 18 km per hour, and in terms of meter per second, it will be 5 meter per second. That means v square will be equals to 25 meter square per second square. The condition is not orbit, and therefore the cyclist will slip while taking the circular turn. Another example. A circular racetrack of radius 300 meter is banked at an angle of 15 degree. If the coefficient of friction between the wheels of race car and the road is 0.2, what is the optimum speed of the race car to avoid wear and tear on its tire, and the maximum permissible speed to avoid slipping? The optimal speed V0 will be equals to Rj tangent theta under the root, and by putting the values in it, you got V0 is equals to 28.1 meter per second, and the maximum permissible speed Vmax is Rg into mu s plus tangent theta upon 1 minus mu s tangent theta under the root, and by putting all the values, you will get 38.1 meter per second. Try to solve more numerical problems from your NCERT back exercise on the topics.